In this video we will see different types of loads. So here the load is either applied force or a couple. So these two, if we applied on a body, it is called as a load. So first category is time dependent load. In that category we have two types of load, static and dynamic. And in static, if we see here, we have either a suddenly applied load, so that with respect to time, if we suddenly applied p magnitude of load on a body, then it is called as suddenly applied load. If we gradually increase the load from 0 to p value, that is the maximum load, so from 0 to p, it is called as gradually applied load. So here if you see in gradually applied load, if we see the deformation of delta L in static case, then it is PL by AE, where L is a length of the road in which we are applying the load, A is a cross sectional area of the road, E is a Young modulus of the material. So this is the formula of delta L, which is a change in length, and stress is simply load applied upon the area of the road. Now if we apply suddenly, then in suddenly applied load, it is 2 times gradually applied load. So change in length will be 2 times the delta L gradually applied load, and stress also becomes the 2 times of that suddenly applied load. So it becomes twice change in length and stress as compared to static load in gradually applied load. So here whatever the change in length will occur or stress will come, twice will occur on suddenly applied load. In dynamic load, if you see, there is impact load and there is fatigue load. So what is impact load? Impact means for a short duration of time, if we suddenly applied the load for very short duration and change the momentum. So here in impact load, the change in length will be impact factor times delta L delta L static, which is gradually applied load. So here PL by AE into impact factor. Similarly, stress also in impact load, impact factor times sigma static in gradually applied load, P by A into impact factor, and the impact factor will be 1 plus under root of 1 plus 2h by delta static. So this delta static is PL by AE, which is for gradually applied load. So this is based reference for all the formulas. So here impact factor we have to calculate, and height is h, height from which the load is dropped. If I suddenly drop this pan from here, then the height is h, and whatever the deformation is when we applied the load gradually, PL by AE. So like this we can calculate impact factor, and we can place it here, and we can find the change in length and stress. So now this impact factor is 2 for suddenly applied load. If we place impact factor as 2, then it is some suddenly applied load, because here if you see height is 0. If I just suddenly drop from my hand to the table, then it is suddenly applied load. But if there is some height with the table, then it is called as impact load. So if it is 2, then it is suddenly applied load. If it is higher than 2, then it is impact load. So impact factor is important here, and if you place height equal to 0, then it will come out as a 2, 1 plus 1. So that says us it is a suddenly applied load. So in gradual load, we simply dropping our load slowly on this, like I drop this pan slowly on the table. But in suddenly applied load, I simply remove the load when it touches, I remove it, and in impact load I drop it from certain height. So that is the basic difference. In fatigue load, we have either magnitude of load changes, like the value, let's say it's a 10 Newton, then it is 20 Newton, and direction changes, means from plus 10 to minus 10, means compressive load to tensile load we changing, or we changing both, either we changing magnitude, direction, and we are changing magnitude and direction combined. So these three variable we change with time, then it is called as fatigue load. The other category is time direction dependent. First was time dependent, the other category is direction dependent. We have two directions generally, normal direction and shear direction. Normal direction is perpendicular to the surface, and shear direction is parallel to the surface. So in normal direction, you see on this inclined surface there is normal perpendicular to the surface, and this parallel to the surface is shear load. So these are the two basic category with respect to direction. And the other category is area dependent. So in area dependent we have two categories, concentrated load or distributed load. In concentrated load, if point load is there on certain points, let's say this is a simply supported beam, here there are 2 points where load is acting, so it is a point load. Moment, this is a concentrated moment where moment is acting at some point, so these are concentrated load. Distributed load, it is distributed over a length. So uniformly distributed load means equally distributed on the length. Uniformly distributed moment means equally moment is distributed on the length. Uniformly varying load means it is varying with respect to length. So here it is 0, here it is maximum, and it is having a linear relationship, and it is varying with the length. Parabolic means it is having a parabolic curvature of the load, and its magnitude is changing as a curvature of the parabola. So here it is maximum, here it is 0, and in between it is a curve of parabola. So these are basic categories of loads. You do not have to remember these loads, but you have to gain some basic ideas of different types of loads to have calculation based on that, and numerical you have to solve as per what load is applied, and you just have to get the idea of these different kinds of loads. So thank you for watching this video. See you in the next video.